Welcome to part 19 of Matrix and Determinant series. In this part, we will see how to find the determinant of a joint of a 3 by 3 matrix, of which the elements are not yet given. If matrix A is a 3 by 3 matrix of the form like this, and B inverse times A transpose equal to twice of identity matrix, where B is a 3 by 3 matrix and I is identity matrix of order 3, then what is determinant of adjoint of B? What we are asked is to find determinant of adjoint of matrix B, but the given in this equation is B inverse. We know that both of them have mathematical relationship with matrix B and its determinant. So let's start by drawing those mathematical relationships. Determinant of adjoint of B equal to determinant of B is the power of n minus 1, where n is the order of matrix B. It's already stated in the question that order of matrix B is 3. So determinant of matrix B is the power of n minus 1 equal to determinant of matrix B is the power of n is 3 minus 1, which is equal to determinant of matrix B is the power of 3 minus 1 is 2. It's always true that for a 3 by 3 matrix, determinant of adjoint of B equal to determinant of matrix B squared. This relationship tells us that if we can solve determinant of matrix B, it's simple to calculate determinant of adjoint of B. To find determinant of matrix B, let's focus on the given equation and take the determinant of both the left and the right hand side expressions, meaning determinant of B inverse times A transpose equal to determinant of twice of identity matrix. This implies determinant of B inverse times A transpose means determinant of B inverse times determinant of A transpose, which is equal to 2 cubed times determinant of identity matrix, where this 2 is the given constant and 3, which is in the power, is the order of identity matrix. Determinant of B inverse can be expressed as 1 over determinant of B, because the determinant of a given matrix is always equal to 1 over the determinant of its inverse, times determinant of A transpose equal to 2 cubed means 8 times determinant of identity matrix is always 1. This implies 1 times determinant of A transpose is determinant of A transpose divided by determinant of B equal to 8 times 1 is 8. The unknown we are going to solve is determinant of B. So let's write determinant of B in terms of determinant of A transpose and the constant 8. That is simply switching determinant of B and 8, meaning determinant of B equal to determinant of A transpose divided by 8. We know that the determinant of a matrix is equal to the determinant of its transpose. So the question can be expressed as determinant of A transpose divided by 8 equal to determinant of A transpose means determinant of A divided by 8. Matrix A is already given, so we can solve determinant of A. Determinant of matrix A equal to the determinant of a 3 by 3 matrix is solved by expressing the matrix as the sum of the determinant of 3 2 by 2 matrices, taking one row or column of a given matrix as a coefficient. In doing so, it's advisable to choose a row or column containing more 0 as a coefficient. Here, we can't find a row or column containing more than 1 0. Hence, it's good to choose a row or column containing 1 0. For this particular case, let's choose row 1 as a coefficient. We know that the sign of the coefficient alternates between positive and negative, starting from row 1, column 1 entry. The first coefficient is 0, so no need to include it in the calculation because 0 times the determinant is 0, and adding or subtracting 0 doesn't bring any change in the final result. The coefficient of 1 is negative, thus minus 1 times the determinant of the second 2 by 2 matrix. We will find the matrix elements later. First, let's form the skeleton. The coefficient of 2 is positive, hence plus 2 times the determinant of the third 2 by 2 matrix. To find the elements of the 2 by 2 matrices, we have to cross out row and column containing the coefficient. This one is in row 1, column 2. Crossing them out left us with negative 2, 0 in the first row of the 2 by 2 matrix and 1, 4 in the second row of the matrix. This 2 is in row 1, column 3. Thus, eliminating row 1 and column 3 gives us negative 2, negative 1 in row 1 of the 2 by 2 matrix and 1, 2 in row 2 of the matrix. The determinant of the 2 by 2 matrix is simply the difference between the product of main diagonal elements and the product of the remaining 2 elements. Hence, the determinant of this matrix is equal to negative 1 times negative 2 times 4 minus 1 times 0 plus 2 times negative 2 times 2 minus 1 times negative 1, which is equal to negative 1 times negative 2 times 4 is negative 8 minus 1 times 0 is 0 plus 2 times negative 2 times 2 is negative 4. 1 times negative 1 is negative 1 minus negative 1 means plus 1, which is equal to negative 8 minus 0 is negative 8. Negative 1 times negative 8 is positive 8 plus negative 4 plus 1 is negative 3. 2 times negative 3 gives us negative 6. 8 plus negative 6 equal to positive 2. Therefore, the determinant of matrix A is 2. We already figured out that determinant of matrix B equal to determinant of A divided by 8, which is equal to determinant of A is already determined as 2 divided by 8. Simplifying 2 over 8 gives us 1 over 4. Once we determine determinant of matrix B, we can easily solve determinant of adjoint of B because we discovered that determinant of adjoint of B equal to determinant of B square, which is equal to 1 over 4 square. 1 over 4 square means 1 over 16. This concludes part 19. Hope you enjoyed all the explanations. If you have any doubt, please jot down on the comment section. Stay safe.